Today, we're diving into a fascinating topic. Why is space completely silent? Space, often called the final frontier, has intrigued humanity for centuries. One of its most mysterious aspects is its profound silence. Let's explore why space is so quiet. First, let's understand sound. Sound is a vibration that travels through a medium like air, water, or solids. These vibrations create pressure waves that our ears interpret as sound. But what happens when there is no medium for these vibrations to travel through? This brings us to the vacuum of space. Space is nearly a perfect vacuum, meaning it lacks the air and particles necessary to carry sound waves. Without a medium, the pressure waves that create sound can't travel. That's why space is completely silent. Consider how sound works on Earth. When you speak, your vocal cords create vibrations. These vibrations travel through the air to reach someone else's ears. But in the vacuum of space, there are no molecules to carry those vibrations from one point to another. Astronauts face this silence firsthand. Inside their spacecraft, they can communicate because the air inside allows sound to travel. However, once they step outside into the vacuum of space, they rely on radio communication, which uses electromagnetic waves, not sound waves, to transmit messages. This principle is why you can't hear an explosion in space, despite what many movies depict. Explosions create sound through rapid air movement and pressure changes. But in space, there's no air to move, making them eerily silent. Yet, space isn't entirely devoid of activity. There are electromagnetic waves, cosmic rays, and other forms of radiation constantly moving through space. However, these don't produce sound as we know it because they don't require a medium to travel. Interestingly, scientists have found ways to listen to space. Instruments can detect vibrations and convert them into sounds we can hear. For example, NASA's Voyager spacecraft captured the sounds of interstellar space by measuring vibrations of plasma waves. These converted sounds give us a unique way to experience space, translating otherwise silent phenomena into something audible. But it's important to remember that these sounds are artificial constructs made for our understanding. Another aspect of space's silence is psychological. Astronauts often describe the silence of space as profound and surreal. The lack of ambient noise can be disorienting and emphasize the vast emptiness surrounding them. This silence also impacts spacecraft design. Engineers must ensure that communication systems are flawless, as any failure means astronauts can't rely on sound to convey information outside their suits or vehicles. Moreover, the quiet of space allows for certain scientific advantages. Sensitive instruments can operate without interference from sound waves, making space an ideal environment for certain types of observations and experiments. But this silence comes with challenges. For example, monitoring the health and safety of astronauts becomes more complex. Engineers must design systems that account for the unique conditions of space, ensuring that critical sounds, like alarms, can still be perceived. The silence of space also adds to its mystery and allure. It reminds us of the vast, unexplored nature of the universe. Each silent moment is a testament to the difference between life on Earth and the conditions beyond our planet. In conclusion, space is silent because it lacks a medium to carry sound waves. This profound silence is a defining characteristic of the cosmos, shaping how we explore and understand the universe. It's a reminder of the unique and awe-inspiring nature of space. Let's delve deeper into the science. On Earth, sound travels at different speeds depending on the medium. In air, it travels at about 343 meters per second. In water, it moves faster, about 1,484 meters per second, and even faster in solids. But in the vacuum of space, there's no material to carry the sound waves. Another interesting point is that some celestial bodies have atmospheres where sound could potentially travel. For instance, Titan, one of Saturn's moons, has a dense atmosphere. However, this atmosphere is primarily composed of nitrogen and methane, which would affect how sound travels compared to Earth's atmosphere. On Mars, the atmosphere is much thinner than Earth's, consisting mostly of carbon dioxide. This means that while sound can travel on Mars, it would be much quieter and lower pitched than on Earth. Researchers have even used simulations to understand how sound would behave on Mars. The European Space Agency's eerily lander attempted to record sounds on Mars, but unfortunately, it didn't survive the landing. However, NASA's Perseverance rover, which landed on Mars in 2021, has successfully recorded sounds, providing valuable insights into the acoustic properties of the Martian environment. Listening to the recordings from Perseverance, we can hear the sound of the Martian wind, the rover's movements, and even the laser shots from its SuperCam instrument. These sounds help scientists understand the planet's atmosphere and surface interactions. Even though sound can travel in some parts of space, such as on planets with atmospheres, the vast majority of space remains silent. The distances between stars and planets are so immense that even if there were a medium to carry sound, it would take years for it to travel across such vast expanses. Space agencies use radio waves to communicate with spacecraft. These electromagnetic waves can travel through the vacuum of space without needing a medium. This technology allows us to receive data and images from distant missions like Voyager, New Horizons, and the Mars rovers. The silence of space also plays a role in the search for extraterrestrial life. Projects like SETI, Search for Extraterrestrial Intelligence, use radio telescopes to listen for signals from other civilizations. The absence of noise in space makes it easier to detect any potential signals. However, detecting these signals is incredibly challenging. The vast distances and the weak strength of potential signals mean that our instruments must be highly sensitive and operate in environments free from interference, which space's silence helps facilitate. The profound silence of space serves as a backdrop to some of the most powerful events in the universe. Supernovae, black hole mergers, and other cosmic phenomena occur in this silent environment. Their energy and impact undetectable to our ears but observable through other means. Our understanding of space's silence continues to evolve with advancements in technology. As we develop better instruments and methods, we gain more insights into the nature of the cosmos and its silent, yet dynamic, activities. The silence of space challenges our perceptions and drives scientific inquiry. It pushes us to create new ways to explore and understand the universe. From radio telescopes and space probes to new theories about the nature of sound and vibration in different environments. In summary, space is silent because it lacks a medium to carry sound waves. This profound silence shapes our exploration and understanding of the cosmos. It highlights the differences between our planet and the vast, mysterious universe beyond. Thank you for joining us on this journey through the silence of space. If you have any questions or thoughts, feel free to share them. Until next time, keep looking up and wondering about the silent wonders of the universe. As we conclude, remember that the silence of space is not just an absence of sound, but a reminder of the vastness and mystery that lies beyond our world. It invites us to continue exploring, learning, and appreciating the incredible nature of the universe. Thank you for listening.